Rocks from the mantle at the more than 1,000 volcanoes around the planet, when they erupt, they send molten rock originally from the mantle and eject it onto the surface. Sometimes, these eruptions can even bring chunks of the mantle with them, which then solidify via what is known as a mantle xenolith. For example, here is an olivine xenolith from the San Carlos volcanic field in Arizona. Yet, despite all of this volcanic activity, the mantle remains generally unseen by humans due to its sheer depth. This is not the case, however, at a remote Australian island where the mantle is being actively exposed on the surface above sea level. Macquarie Island. The island I am referring to is Macquarie Island, where rock from the mantle and adjacent oceanic crust is being uplifted and pushed higher above sea level at a rate of 11.5 centimeters or 4.5 inches every 100 years. Because of this, the island contains an abundance of highly unusual rock and mineral types, such as this piece of serpentinite. Another example is this piece of dunite, which contains abundant olivine crystals. While this mineral is rare to see in large crystals, in the upper mantle it is one of the most, if not the most common mineral in that layer of the planet. Both of these rock types are part of a rare group of rocks known as an ophiolite. While there are a scattered assortment of ophiolite deposits around the planet, only the one at Macquarie Island, which represents part of the mantle, is being actively and increasingly exposed on a landmass. For context, Macquarie Island is, despite being closer to the South Island of New Zealand, considered part of Tasmania, where it is 1,550 kilometers southeast of the city of Hobart. This island is more than 5 times as long as it is wide, and this fact can be credited to how it formed. A disclaimer: before I describe why this strange geologic oddity of an island exists, I want to first say this. The exact reason why the island is being uplifted is still debated, and despite spending many hours reading an assortment of papers, I could not find an in-depth model. As a result, what I am about to present is a combination of ideas proposed in several